So in this short example, we'll be discussing this short lecture. We'll just go again on the concept of confounding interaction. As I said, interaction is also called effect effect modification. So we'll repeat again just to discuss confounding, interaction, effect modification, and stratification, so that you understand these concepts. So these are just examples of the same thing. Yeah, we will be discussing this in terms of your high alcohol consumption, your low alcohol consumption, and the risk of getting coronary heart disease, where actually smoking can be what and it can be a confounder. Why? Because smoking is related to both coronary heart disease and high alcohol consumption, which then becomes what? And it's a confounder. For those with low alcohol consumption, and most of them, they're not related with smoking, so because of that, they've got a low risk of developing coronary heart disease. So just a graphical picture to try to make sure you understand this, this concept. Then just repeating again the criteria for a variable to be said is a confounder. One, it must be a risk factor for the outcome. It has to be a risk factor for the outcome. There should have a relationship between your confounder and the outcome. Number two, it is associated with the exposure. So there's a relation, there's an association between your confounder and your exposure. And number three, it's not on the causal pathway of exposure to outcome. So this one is not here. The exposure does not lead to this, which then leads to this. So it has to be independent. They have to be independent relationship with outcome and exposure. All these two, they have the relationship between this and this. They have to be independent. So that's what we mean with not in the causal pathway of exposure to outcome. I'll give a good example on it of causal pathway using the same example of high-fat diet to say and congenital heart disease. We know that high-fat diet can lead to high cholesterol, which then leads to congenital heart disease. So in this case, high cholesterol is not a confounder. Why? Because it is in the causal pathway. So this is something which really explains and it's a confounder. Then, what are the possible confounders? The most possible common confounders are age and sex. But you also have other confounders like blood type, socioeconomic status, civil status, social habits, smoking, diet, profession, and education. But most of the confounders which we see in epidemiological research, it's age and and sex. And as I say in the previous lecture, a confounding factor may create an appearance of an exposure outcome relationship that in reality does not exist. So it appears as if there's a relationship between your exposure and your outcome, but in reality, that relationship does not exist. And in that process, you can either underestimate or overestimate the real association. So this is an example. This is data from a case control study where we are measuring the effect, where we are measuring the effect of confounding. So the case control study looked at the relationship between oral contraceptives and the risk of coronary heart disease. So this was the case control studies, and those on contraception, those are not on contraception. So this area for our 2x table, that's the exposure. So in this case, our exposure, yes, is contraception. Our exposure, no, is no contraception. Then our outcome is congenital heart disease. So those who had disease and those who didn't have disease. So in this relationship, if you do your 2x2, your odds ratio, which is your cross product, 39 times 154 divided by 114 times 124, you get an odds ratio of 2.2. So, and you get an odds ratio of 2.2. So in this relationship, you want to assess now, is age and it's a confounder. So remember the criteria for confounder. But first, it has to be a risk factor, and it has to be a risk factor for outcome, which means there should be an association with the outcome. There should be an association with the outcome. It should not be in a causal what? In the causal pathway. So this relationship actually can be assessed. So in this case, this is the same, the same case control studies, and the same case control study with all these things. If you then stratify by age, if you then stratify by age to say, remember, we thought age and we have your age. So one of the criteria, that same case control studies, if you stratify by age, where you have got people less than 40, those who are less than 14, you can then actually assess the relationship of age with our outcome, which is coronary heart disease. Then you can also do the same, where you can assess your relationship between your outcome, between your age and the exposure. So that same case control study, using the numbers, if you split those who are above 40, those who are less than 40, and do your 2x2 tables and calculate your odds ratio, you realize actually there was an association between age and congenital heart disease. Then there was also an association between age and contraception, which is our exposure, and these were the odds ratio, 1.7 and 0.3. And the third criteria, so how do you see? You can actually, as I said, you can actually do the maths and calculate to see if there's an association or there's no association, but by the actual doing of the calculation, like in this case, this is what you get. Then, if you look from, if you analyze in terms of the mechanism, actually, you realize that age is not in the causal pathway between contraception and congenital heart disease. So, because we have assessed all these three conditions, age actually meets the criteria of it being a confound. So the message here in this slide is trying to say you can actually do a process where you actually assess whatever variable you think is a confound by doing the actual associations, where you actually take your data and you try to create now categories based on your confound. So the message here is you can actually test your confound. You can actually test if there's an association between exposure, if there's an association between an outcome. And how do you get that there's an association? You get the associations by calculating your measures of association. In this case, it's in what we are calculating odds ratio. And where are you getting this data? We are just getting this data there. If you split this thing further into age, we can actually create these 2x2 tables, which you can use to perform our association. Then this is another example now, and where we are doing stratified analysis to control for confounding in the same case control study on contraception. So in this case, this one is our crude, and this one is our crude. This slide prior, we thought age, was a G and it was a confounder. We assessed the association between age and outcome, age and G, but now we go to the next stage now, where we want to then assess our contra, and where we then want to assess the effect of age through stratified analysis. Now, from the first lecture, remember we said you stratify according to your confounder. So our confounder age, so we want those less than G, 40 years, and those above G, above 40 years. So we want to see the risk of congenital heart disease from the same 2x2 table. We can actually split it according to those less than 40 years and those more than 40 years, and you can get these numbers for this. So this one is our crude for everything. If you then stratify according to age, which is our confounder, here you'll get an odds ratio of 2.28. Then here you get an odds ratio of 2.28. If you look now, this and this and this and this, they're not different. They're not different. They are more or less the same. Which means in this case, they are more or less the same. Which then that actually age is no any causal effect between our exposure and outcome. It is just a confounder, because if you stratify according to it, you will still get the same odds ratio for those less than 2.8, and the same for those less than 40 and those above 40. I'm not going into detail in terms of these other odds ratio. Yeah, it's a bit complex here. So usually there's a mechanism which you can use to assess, if something is a confounder or is not and it is not a confounder. So in most cases, you have your crude association, which is this, the crude association. Then you have your stratum specific odds ratio, which is this. You can calculate what you call a mentor-Hensel odds ratio, which is this. So you can actually use your crude ratio, your stratum specific odds ratio, and your mentor-Hensel odds ratio to see if it's confounding. But generally, if there's more than 10% difference between your stratum specific odds ratios, which gives you the mentor-Hensel odds ratio, then as compared to the crude, we always say that's confounding, but it's more complex in terms of how you assess this. I think we discussed this with how do you control for confounding. You can do matching for case control. You can do randomization for your RCTs. At analysis stage, you can do your stratification, your standardization, and this one. I think we've discussed this in terms of how to standardize. If you want to compare populations, it's another method which you can use in the analysis stage. And you can do your multivariate analysis, where you then put all the possible variables in one model, which you can use. Then this one is an example of effect modification. So this was a case control study which was conducted in Brazil around in the years 1980s. So in this one, they wanted to see breastfeeding and breastfeeding and not breastfeeding as a risk of developing diarrhea. So in this case, you will see with the infants who are not breastfed, they were 3.6 times more likely to develop diarrhea as compared to those who are breastfeeding, which means breastfeeding was it was needed actually. So is age of the infants a confounding factor? If you stratify this thing according to age, you have those who are less than 1 month of age and those who are more than 1 month of age. You realize there's a huge difference in the odds ratio. This one is 32, and the odds ratio is what? Is 32. 32. If less than one, and remember, less than 1 month of age, if you are not breastfeeding, the chance of developing diarrhea is higher as compared to if you are more than 1 month of age. So in this case now, age is not a confounder, but there's effect modification. Why? Because there's a huge difference. The stratum specific odds ratio, which you get for year and for year, they're different. And so when you are reporting now, you report these stratum specifics for infants and those less than 1 month and those above 1 month. Why? Because they are different. So in this case, age is not a confounder, but is an effect modifier. Why? These two, they are completely different. But if you look in the previous example, and these two for strata and this one, They are more or less the same. But in this example, they are completely opposite actually. Remember, we mentioned this issue of additive and it's synergistic, and which comes as a result of effect modification. These are examples of effect modification and which you can read through. Then how do you check for interaction or effect modification? You stratify, you always stratify. But after you stratify, you compare the measures of association which you get after stratifying with the odds and with the crude one. And then you check if the effect of exposure differs within the levels of potential what modifier. The stratification can be used to control for confounding, or to look for interaction or effect modification. So just a repetition again, is there an association? So strength of association between exposure and outcome, how do you get it between an odds ratio and the GRR? How do, then the next thing after assessing an association, you need to assess now. The first thing when you're doing your analysis, you have your association between exposure and outcome. The next stage, you want to look, is there a potential confounding factor, which is a third variable, which is related to either both the outcome and the exposure. I explained, you can actually do some maths, some analysis, where you can actually do 2 by 2 tables, depending with your study type, where you assess if your third variable is associated with this, with the exposure, if your third variable is associated with this. Then from reasoning, is this third variable not also associated, is it also not in the causal pathway? Then from there, you can conclude whether it's a confounder or it's not a confounder. Then interaction, we explained how you assess for interaction. Is mainly your stratification across your third variable, which is G, which is V. Stratification, it helps you to see both confounding and interaction. You then assess the difference in the odds ratios and in the odds ratio which you get. These ones, I will not go in detail in terms of how do you do it, but there's a way for you to really see whether it's interaction or it's an effect modification. It's a bit complex, but there's steps which you can use to see whether it's effect modification or it's interaction, where you use all these algorithms and try to, it can be complex, and it can be very complex for you. After doing your stratification, it can be a bit complex for you to see whether it's interaction or effect modification. I will not go in detail in this, but these are more statistical things. But just to know, there are other statistical ways which can be used to assess if there's effect modification or there's interaction. So I hope from the lessons which you have, you now understand a bit of what is confounding. You know some techniques which you can use to control for your confounding. You know the difference between confounding and interaction. Interaction, the synergistic or the multiplicative effect, where confounding actually distorts the relationship. Then we discussed the bit of calculating your stratum-specific odds ratio and try to compare them with the odds to whether to assess whether it's confounding or it's whether it's confounding or it's effect modification. Yes, you may need to understand that, but it's beyond the scope of your level. But just understand there are methods which can be used to really assess that. Otherwise, this is the end of the lecture.